The simulation began to glitch. On March 14, 2023, at exactly 1:59 p.m. Coordinated Universal Time, 17 quantum computers in different countries simultaneously crashed. Not a power failure. Not a hack. They all displayed the same error message: observer collision detected. The engineers couldn't explain it. The physicists refused to publish their findings. And the only person who predicted it? A graduate student who'd been banned from every academic forum for claiming he'd found a mathematical signature, a fingerprint, proving our universe runs on a substrate. 3 weeks later, he vanished. But before he disappeared, he sent one encrypted file to 14 random people across the globe. The subject line: "It's not a metaphor." What did they see? And why did 12 of them immediately delete their social media accounts? You need to understand something about simulations: they're not magic. They're compression algorithms with rules. And every rule has a breaking point. In video games, developers use something called level of detail scaling. Objects far away are rendered with fewer polygons. The tree 50 meters from your character? It's basically a green triangle. Your brain accepts this because you're not looking directly at it. But here's where it gets uncomfortable. Quantum mechanics works exactly the same way. When you're not observing a particle, it doesn't have a defined position. It exists as a probability wave, a cloud of maybe. The universe only renders the details when something is actively measuring it. We call this wave function collapse, but what if it's just computational efficiency? The graduate student, his name was Alex Mercer, he wasn't studying quantum mechanics. He was studying anomalies. Moments when the universe's compression algorithm stutters. In 2019, a security camera in Singapore captured something impossible. A pedestrian walking down the street, normal, unremarkable, except for 0.2 seconds, the timestamp shows her in two positions simultaneously, 3 meters apart. Same clothes. Same gait. Same person. The footage was authenticated by 3 independent labs. No tampering. No editing. The woman in the video? She has no memory of the moment. But she does remember feeling strange that day. Like reality lagged. Alex collected 247 cases like this. Security footage. Traffic cameras. Phone videos. All showing the same thing. Reality duplicating frames, like a video buffer struggling to load. But the quantum computers crashing? That was different. That was the universe catching itself in the act. Quantum computers work by exploiting superposition. They exist in multiple states simultaneously until observed. They're essentially asking the universe to hold contradictory information at the same time. And usually, the universe handles it. Usually. But on March 14, at 1:59 p.m., 17 of them asked the universe the same question at the exact same microsecond. And the universe flinched. Inside that encrypted file Alex sent, there was a 47-page proof. Not philosophy. Mathematics. He'd found what he called observer limit boundaries, a threshold where too much information being measured in too small a time frame causes the rendering engine to deprioritize accuracy for speed. Think of it like this: your computer can render one explosion beautifully. But spawn 100 explosions at once? The frame rate tanks. Details get dropped. Physics becomes approximate. Alex's math suggested our universe has a frame budget. A maximum amount of information that can be precisely rendered per Planck time unit. That's 10 to the power of 43 seconds, the smallest meaningful slice of time. And when you exceed that budget, the universe does what any overloaded system does. It approximates. It guesses. It glitches. Let's talk about the double-slit experiment again, but the version they don't teach in schools. In 1998, researchers at the Weizmann Institute did something clever. They set up the experiment so the detector would record which slit the particle went through, but they didn't look at the data until after the experiment. The particles still behaved like they were being watched. The interference pattern disappeared. The universe knew the information would eventually be observed, so it rendered the particles as definite, not probable. It was rendering the future based on predicted observation. That's not physics. That's optimization. Alec took this further. He designed an experiment where the observation would be determined by a truly random quantum event that hadn't happened yet. The particle would have to be in superposition until the future decided whether it was being watched. He ran it 400 times. 397 times, it worked as predicted. But 13 times? The particle appeared before the random event determined it should exist. By exactly 10 to the power of 43 seconds. 1 Planck time. 1 frame. The universe was guessing when to render, and occasionally, it guessed wrong. That equation he left behind? It wasn't incomplete because he couldn't solve it. It was incomplete because the answer was a coordinate. 42.3601 degrees north, 71.0589 degrees west MIT's Center for Theoretical Physics. Specifically, Lab 7 in the basement. 2 of the 14 people who received his file were MIT researchers. They went to Lab 7. The door was locked, officially decommissioned since 2015. But when they got inside, one terminal was running. Had been running, according to system logs, for 8 years. No power source. No network connection. Just running. The program on screen was a simulation. A cellular automaton, like Conway's Game of Life, but infinitely more complex. And in that simulation, there were entities. Digital life forms that had evolved from random noise over 8 years of continuous processing. And these entities, these emergent patterns in the code, they were building something. They were building detectors. Trying to measure the boundaries of their universe. Trying to prove they were in a simulation. And 3 days after the researchers found this terminal, it displayed a new message, one it had written itself. We see you seeing US. March 14, 1:59 p.m. 17 quantum computers asking the universe to hold contradictory information simultaneously. But what if they weren't asking? What if they were being asked? Every quantum computer that crashed received the same error. Observer collision detected. Not a collision of observations. A collision of observers. What if something in our simulation was trying to observe us the same moment we were trying to observe it? 2 render cycles trying to compute each other simultaneously. An infinite loop. Alex's final theory, the one that got him deleted from existence, was this: we're not looking for proof we're in a simulation. We're the proof. We're the entities in someone else's Lab 7, building quantum computers, trying to measure the boundaries of our reality. And every time we get close, every time we build a detector sensitive enough, the parent simulation has to intervene. Has to crash the system. Has to remove the observer. 63 physicists have vanished since 2015. All working on quantum observation experiments. All disappeared within 72 hours of a breakthrough. No bodies. No evidence. Just absences where people used to be. One of the 14 people who received Alex's file. She's still active. Still online. And last month, she posted something on an encrypted forum. I've been running his numbers with updated data. The glitches are accelerating. Not randomly. Exponentially. Whatever's running this is struggling to maintain coherence. And I think I know why. We're approaching computational capacity. Too many observers. Too many measurements. Too much information being rendered simultaneously. The simulation is running out of processing power. And when a simulation runs out of resources, it does one of two things. It crashes, or it prunes. Guess which one leaves evidence? She posted that 14 days ago. Her account went silent 5 days ago. Her apartment is empty. Her family says she's traveling. But her passport never left the country. Here's what keeps me awake. If we're in a simulation, and we prove it definitively, what happens? Do we get promoted to the parent reality? Do we get to meet our programmers? Or do we just get deleted? A bug fixed. An anomaly patched. The Fermi paradox asks, where is everyone? Where are all the alien civilizations? Maybe they all reached the same point we're reaching. Maybe they all built their quantum computers. Maybe they all tried to peek behind the curtain. And maybe the silence we hear when we search the cosmos isn't the absence of life. Maybe it's the sound of the universe deleting its mistakes. That quantum computer error message. Observer collision detected. What if it wasn't an error at all? What if it was a warning? That incomplete equation had one unsolved variable. He labeled it delta t, delta time. The time remaining until observer saturation. Until the system prunes. 3 independent mathematicians have now solved it using his framework. They all got the same answer. 18 months. 18 months from his disappearance. That's August 2024. That was 6 months ago. Either his math was wrong, or we're living on borrowed processing power. You felt that, didn't you? That split second where something felt off. Like reality skipped a frame? Start paying attention. You'll notice them everywhere now. Welcome to observer status. You can't unwatch this.